Kester, Penn State. Excellent talk. Doxil, amphotericin, many drugs encapsulated within liposomes, next generation liposome, ceramide, like you and I are both developing. But we're not really seeing actively targeted liposomes yet, i.e. through phospholipid maleimide chemistries. Do you think when we actually put these targeting moieties on, they will actually hurt the pegylation and EPR effects due to these highly pegylated DSPEs? Is there going to be a point where active targeting no longer makes a liposome stealthy, et cetera?
Okay, I think this is the easy part of the question, because I think we overcome this problem long ago. I mean, we can make very good targeted liposomes that will have the same circulation time and will reach the tumor. But, and here is a big, big but. What happened with this liposome? Once they extravasate, they find the first layer of cells right near the blood vessels. They bind there, and they block the way for other liposomes to come. So actually what's happening, if there is no very fast internalization, I mean very fast, I mean a matter of minutes, not seconds, but let's say 10 minutes, 15 minutes, 20 minutes. If this doesn't happen, what you get is a very good labeling, very good imaging. We have fantastic imaging of all the tumor periphery, but nothing goes in. And actually, most of these liposomes perform worse than Doxil perform. I know one case that there is a very fast internalization, and then the active targeting working. We have to remember that active targeting, first of all, depended 100% of the passive targeting on the EPR effect. If it cannot extravasate, the fact that you have ligand will do nothing to your liposome. So you need the EPR effect, number one. Then you need a fast internalization. I have a line of labs all over the world trying to come to me and say, help us. I said, you come first, you show me internalization, I'll give people, I'll give money, I'll do work. If not, do it yourself.
Another question?
I agree.
Hi, Stephen Lee, Ohio State. I just noticed on your comparison of Doxil to doxorubicin that you mentioned the hand and foot syndrome, and you also showed up there that mucositis was apparently worse.
No,
with
better. Mucositis better.
Oh,
No grade 3 and 4 at all, while you get a lot with doxorubicin itself. Only foot and hand syndrome.
Okay, can you speak to the mechanism? Why is it exacerbated?
Yeah, definitely. Okay, that's a fascinating effect. Actually, in 91, when we start looking at patient, at the second patient, we got the effect. And Alberto and me were shocked. So we didn't know what to do, but then some patients didn't show it, and some show it. It's about something like 30–40% of the patients showed this effect. You know, it's not life-threatening. Physicians don't care that much about it. But for the patient, it's really traumatic because he cannot sit, he cannot use his hands, and problems like that. And it shows up, which is the most problematic for the patient, to see him looking so badly. So the first thing the company did, and that's a decision by many physicians together, is they increased the time between administration from 3 weeks to 4 weeks. It may be compromised, some compromise of the activity. We don't know because we couldn't test it. No one could test it. When I say we now, it's basically all the people involved, not myself, even not Alberto and myself anymore. So I think by this, they lower the frequency quite dramatically. Then there are different tricks, like putting ice on the end and so, that lower. But now the mechanism. Actually, when we start looking at the literature, you know, doxorubicin, was approved, was developed by Pharm Italia. It's interesting. It's a kind of derived of earth bacteria near the Adriatic field. That's why it's called the adriamycin. And I met with these Adria people, very interesting family. I don't know, now they are not very good anymore, but they used to be really, they did a lot of money from this drug. It was really a machine to make money, the doxorubicin. And what at the beginning, the idea was that if you expose the patient to a very low level of drug under slow infusion for 2 weeks, the patient will benefit the most because you will not get cardiotoxicity. That was the known effect then. So they start doing this treatment, and what happened? All the patients got foot and hand syndrome. There are about 2-3 publications about it that are hard to find, but we found them, and that's actually lightened the red light in our head that what's really happening is that the very long exposure of the keratinocyte is the reason for the disease, so for the side effect or whatever you call it. And the problem is that we have pharmacokinetics which is too long. I told you 100 hours is the T-half. So drug can be found in the blood after 500 hours. Divided by 24, it's 20 days or so, something like that. Very, very long time. Okay, so I think when you give the second dose after another 4, you still have some drug in. So this is the problem. And I think the way to overcome it is to find a way that you can lower somewhat. When we lower it too much, doxorubicin lost its efficacy completely, or very, very low efficacy. FDA will never approve something like that. So we were looking for a way to reduce shorten the half-life by about 30-35%. And a few years ago, we found it. So we filed a new patent, and now this is the new generation Doxig we are going to develop, hopefully, if it will. We are at the end of the efficacy. The efficacy has to be good, and human has to prove the same profile that we can see in animal, lowering the PPE.
We have one more